of AI. And just a brief introduction. Yes. Yeah, sorry for that. Yeah, okay. So, yeah, we'll go ahead with the session now, and we'll let all the faculties join in during the course of the session. Our next session is going to be taken by Dr. DP Gaikwad, sir. He'll be a third honorable speaker for the day who will guide us through Unit 5 and 6. Just a brief introduction about him. He is currently working as a professor and head of department for the computer department at AISSMS College of Engineering, Pune. He is a proud holder of a BE and MTech degree along with a PhD degree in computer science and engineering with an experience of over 25 years. He has research publications in over 37 international and national journals with 17 plus international and national conferences. He has also reviewed in 30 plus international conferences and 10 international journals. He is a recipient of a number of awards and recognition throughout his career. His contributions can also be seen in a number of books published, and he has been invited as an honored speaker in a number of conference and events. He has also received a fully sponsored trip to UK to Stanford Shrine University, Stanford, UK, for further research work. And without wasting any further time, I kindly request Dr. DP Gaikwad sir to please take the forum and start with his session, please. Sir, I believe you're on mute, sir.
Hello.
Yes, sir, you're audible now. Please go ahead.
So thank you for a nice introduction. Just I want to tell you, I cannot switch my video on because there is a problem on my team.
Sure, sir. No, no issues. You can
Is
please
it okay?
continue.
Okay. Thank
Yes,
you.
sir, definitely.
Thank you. So once again, thank you the coordinators and Honorable Varsha Madam, Pramod Patil, specifically Uday sir for giving the opportunity to give the session on this new syllabus introducing the TE computer as artificial intelligence. So today's the agenda of this session is before starting our logical agents and actual chapter 4 and 5, I want to just define the artificial intelligence. Already previous speakers have defined artificial intelligence. Jayshree madam and Rajeshwari madam must have defined it, but for continuation, I just want to define or redefine the artificial intelligence. Then introduction to the logical agent. Then we will discuss what is the knowledge based agent. Then propositional logic syntax and semantics, first order logic, that is predicate logic. Then we will discuss ontology, then inference in first logic, rules of the inferences, forward and backward inferences, and lastly, we will discuss problem solving using planning. Am I audible?
Yes, sir, you're audible, sir. Everything is
Yes.
visible and you're audible.
Thank you. Thank you. So, as already defined by the Jayshree madam, what is the artificial intelligence? Specifically, there are two very important definitions of artificial intelligence. One is the art of creating machines that perform the function that require intelligence when performed by the people, which is defined in 1990 by Kurzweil. So this definition is a very important for the chapter 5 and 6. Second definition, the branch of computer science that is concerned with the automation of intelligent behavior. Specifically, behavior is very important and which is defined by the Stubblefield in 1993. So actually, Madam have also discussed about the different approaches of artificial intelligence. One, thinking humanly is the first approach. Then second, thinking rationally, acting humanly, and acting rationally. Specifically, from these four approaches of artificial intelligence, you can conclude that definition first and seconds are concerned with thought process and reasoning process. 3 and 4 addresses the behavior, means human behavior. 3, 1 and 3 measures success in terms of fidelity to the human performance, and the second and fourth measure against an idea or ideal idea performance measure, that is called as the rationality. Already we have discussed, the previous resource persons have discussed what is the rationality, but in nutshell, a system is a rational if it does the right things with right reasoning given what it knows. Means what? The system knows many things in terms of the sentences, and using these sentences, by using applying the reasoning process, computer or system should give the right decision. So that is called the rationality or rational. Already, again, just I want to discuss what is the agent. Agent play the major role in AI, artificial intelligence, in searching and other techniques of the artificial intelligence. So what is the agent? Agent is anything that can be viewed as a perceiving. Perceiving means taking input from the environment through sensors and acting upon that environment through the actuators. There may be some environments are difficult than other, because the agent works into the different situations in different environment, and environment are not same. Some are simple, some are difficult. So how to handle these environments, we will discuss in this year. And environment influence the design of suitable agents also. Is environment is a very important. For example, human agent, eyes, ears, and other organs for the sensors, hands, legs, whole tracks can act as the actuators. In computer or in robotics, camera you can call as agent, or sensor, and various motors which are used for different activities we can call as actuators. Now, what is the software agent? The software agent is a kind of combinations of the architecture plus some program, that is called the agent, which can receive the information from the keyboard or keystrokes, from file contents and network packets as a sensory input, and acts on the environment by displaying on the screen or writing files and sending network packets. So this is a functionality of the software based agent. Now, what is the rational agent? Already discussed by other resources about the agent, but this session is based on the rational agent. For each possible percept or input sequence, a rational agent should select an action that is expected to maximize its performance measure, given the evidence provided by the percept or input sequence and whatever built-in knowledge the agent has. So this type of the agent is called as the rational agent. Now, in real life, who is a rational agent? For example, here example I have given taxi driver. It may act as rationally. Then the performance measures are safe, fast, legal, then comfortable trips, maximize profit. So these are the measures of the performance of the taxi driver. Environment, road, other traffic, pedestrians, and customers and all, actuators, strings, steering, accelerator, brake, signal, and so on. Sensor, camera, GPS, odometer, and all. So taxi driver may be called as a rational agent in real life. So what you have to do, you have to train computer, or you have to write a program in computer which can work as a taxi driver. Means taxi driver can take a decision at particular location. Means after reaching at particular location, he take left or right, and all these things are done by the taxi driver because he is intelligent. So the computer is a fast device, computing device, but intelligence is very difficult to introduce in computer, like the human or taxi driver in our example. So we try to introduce intelligence in computer to take the proper decisions on different situation and different environment. So this is very important, situation and environment. So if the environment change, definitely the taxi driver can take the decision. Suppose in traveling, if roads are not there or proper, if the traffic is more, so he take the decision and he apply another road or change his route. So this is called as a environment actually. And environment change may change at any time. Means it's time dependent. Okay. So such type of the intelligence you can introduce by writing the rational software agent. I would say software agent. Now what rational agent is and what are the functionalities, or what are the jobs of the rational agents? All computer programs do something, but computer agents are expected to do more. It should be operate autonomously, pursue their environment. This is very important. Persist over a prolonged time period. Adopt to change. Already I have taken example of that. Create and pursue the goals. This driver pursue goals by dropping passenger at demanded or his location. So rational agent is one that acts so as to achieve the best outcome in terms of money or in terms of the short route and so on. In our example, I'm talking about the example when there is a uncertainty. Uncertainty means what? The environment may change, and there is no certainty of, means I cannot decide that I will follow one road while traveling. I have to take decision. Okay, so uncertainty. So that should be implement into the computer, and that type of the program or agent, specifically agent, is called as rational. Law of thought approach to the artificial intelligence gives emphasis on the correct inferences. Inferences means what? The final decision, and that should be taken correctly, not wrongly. So that is called the rational agent. Making correct inferences is somewhat part of being a rational agent. This is the job of the rational agent. Act rationally is to reason logically. So decision should take in logical manner. That is very important. To the conclusion that a given action will achieve one's goals, and then to act on that conclusion. So conclusion is very important. Means proper decision taking is very important. But after taking decision, Again, the agent should act on that. Okay, so this is called as a rational agent. Now, what is the job of the artificial intelligence? Is to design an agent program that implement agent function. Now, what is the agent function? Agent function is used for mapping, or it is used to map percept percepts means input to the action. We assume this program, okay, or function will run on some sort of the computing device that is called the architecture. So already we have discussed what is the agent. Agent is equal to architecture means computing device plus program. Now we have seen some in first and second unit. We have studied different searching algorithm. They may act as agent but not rationally. Okay, so searching program, for example, tree search, then graph search, hill climbing, then simulated annealing, then adversarial search. Okay. These are called as a problem solving agent. Okay, but there are some problems with the problem solving agent. Okay, the problem solving agents know things, but only in a very limited, inflexible sense. For example, the transition model for the 8 puzzle you might have studied in previous session. Knowledge of what the action do is hidden inside the domain specific code of the result function. Means it is actually problem solving agents work on the domain specific applications. It can be used to predict the outcome of the action, but not to deduce that two tiles cannot occupy the same space, or that state with odd parity cannot be reached from the state with even parity. So this deduction is impossible for the problem solving agents. The atomic representation used by the problem solving agents are also very limiting, and they work into the environment which is a partial, or in partial observable environment. An agent only choice for presenting what it knows about the current state is to list all the possible concrete states. This is the drawback of the problem solving agent. And these agents or problem solving searching not suitable for in large environment. For example, take the example of a taxi driver and all. So in this environment, problem solving agent may not suitable for solving that problem actually. Now coming to the rational and logical agent. Okay, rational means logical. So logical agent means what? It is like the human. Now what is the human? Actually human does, human, it seems, know things, and what they know help them do things. Okay, so this sentence actually is used to describe how the intelligence of humans is achieved, not by reflects the mechanism, but by process of reasoning. This is very important. Reasoning. The human do decision by using the reasoning technique that operate on the internal representations of the knowledge. So this is called as the logical agent when we apply it in computer. And artificial intelligence, this approach to intelligence is embodied in knowledge-based agent. Introduce the idea of representing the state as assignment of the values to the variable. Okay, so this idea is introduced into the knowledge based agent or logical agent. Means variable should be given any value. Normally the system is designed with the variables, but that variable we may replaced by actual or sound agent or sound actor. So this is a very important concept of knowledge based agent. And this step is in right direction, enabling some part of the agent, not complete agent, but some part of the agent to work in a domain independent way and allow for more efficient algorithm. Means this agent can also can be used by the other techniques. Means for example, agent is searching. Sometimes to optimize that searching problem, that agent can use the another optimal algorithms. So that is the case actually. For example, optimal algorithm, optimization algorithm such as genetic algorithm or other bio-inspired algorithm also can be used. So this is the complete definitions of the logical agent. Logical agent follows the logic for logical conclusion, and it is used to develop a logic as a general class of representation to support the knowledge based agent. Actually, you can develop logic. And what is the function of the logic? To support the knowledge based agent. Such agents can combine and recombine the information to suit countless purposes. Knowledge based agent can accept the new task in the form of explicitly described goals. They can achieve competence quickly by being told or learning new knowledge about the environment. So getting the knowledge of environment is very important because already we have discussed the environment get changed timely or it is depend on the time. They can adapt to changes in the environment by updating the relevant knowledge. And if the agent, software agent can do all these things, that is called the logical agent. Specifically, it should be do reasoning. It should be act according to the environment, and it should be do some changes in environment using the new knowledge. So this is called as a logical agent. So before starting the logical agent in detail, we must know what is the knowledge based agent. Actually, the center component of the knowledge based agent is its knowledge base. Definitely, it is the database, okay, which consists of some sentences. And these sentences may be some qualifiers and all. So we will discuss what is the sentences and how you can combine, how you can create the new sentence using some quantifiers and some operators. Each sentence is expressed in a language called as knowledge representation language and represents some assertions about the word. Axiom is a one type of the sentence without being derived from the other sentence. It is the unique sentence or basic sentence, I would say. Using the basic sentence, I can create the new sentence. Now, what is this new sentence? The new sentence may be combinations of these axioms or basic sentence to deduce or to produce the new knowledge. And actually, computer know these sentences and do some operations using the operators and quantifiers and all. There are many things we will discuss in next some slides. But the computer can form the new sentence by doing reasoning. Okay. So before formations of the new sentence, internal process or agent do some reasoning, and after doing reasoning, it form the new sentence, means rational sentence, meaningful sentence, correct sentence. So that is the actually process of the knowledge base agent. There must be a way to add the new sentence to the knowledge base and a way to query what is known. So this is these two process are very important into the knowledge base agent. The standard names for these operations are tail and ask respectively. Both, so these two operations are very important into the knowledge base agent. So both tail and ask operations mean involve the inference. Already we have discussed what is the inference. Okay, inference means to take the proper decision. Inference for deriving the new sentence from old by using the reasoning. Now, what is the job of the inference? Inference must obey the requirement that when one asks a question of the knowledge base, the answer should follow from what has been told, instilled to the knowledge base previously. So this is the job of the inference. It is the process into the knowledge base agent program. Inference process should not make things up as it goes along. It should be do reasoning. So this is the diagram which represent or depict the knowledge base agent. Like all agent, knowledge base agent or logical agent takes a percept means input, percept as an input and return an action. The agent maintain a knowledge base KB which may initially contain some background knowledge. Background knowledge means basic sentences which are stored into the KB. And each time the agent program is called and it does three things. First thing is what? Tells. Then ask and do some logical process or reasoning. So what is the tail process or the tail function? The knowledge base what it pursue means actually the agent tells to the knowledge base what it pursue, what is the input. Then agent asks the knowledge base what action it should perform, and the knowledge base give the answer to the agent what to do. And in the process of answering this query, extensive reasoning may be done about the current state of the world, its current environment or current state of the environment, about the outcome of the possible action sequence and so on. So this is very important part of the knowledge base agent. Reasoning is very important. Telling, asking is, these are the basic actions or tasks by the agent, but answering this query which is asked by the agent is very important. And to give the this answer, extensive reasoning is very important in the knowledge based agent. And third action is that the agent program tells the knowledge base which action was chosen. Means this is a reply to the knowledge base by the agent, which action is taken, and the agent execute the action. But okay, so these are the three very important process or things which are done by the logical agent. So this is a very basic algorithm for knowledge base agent. So if you see the function KB agent means knowledge base agent percept means input, it take the input and return some actions. Persist means variables, for example. Knowledge base KB, then T is a counter, initially it is 0, indicating time. Now first function tell to the KB, make percept sentence with the time and input. Action ask KB and do the make action query depending on time. And then tell KB make action sentence means do the action on the time, and it will continue in time. So what is the meaning of this algorithm? It gives or percept agent add the percept means input to its knowledge base, ask the knowledge base for the best action, and tell the knowledge base that it has in fact taken that action. So specifically, these three functions I would like to discuss. What is the make, percept sentence, construct a sentence asserting that the agent pursued, means it tell about the input at the given time. Then make action query means what? Construct a sentence that asks what action should be done at the current time to the knowledge base. Make action sentence, it it is used to choose the proper action which is answered by the knowledge base or database, and finally it do the action and proceed for the further iterations. And it is a repetitive task actually. T in this algorithm, t plus 1 means it may be the repeated. Okay, so this is actually knowledge base agent. Now really actually this topic means unit 5 start here. So I have spent 10 minutes for just basic things, what is the agent and what is the knowledge base agent, logic base agent, rational agent, and on. Actually, this topic or this unit is concerned with the logic, reasoning, and interference. Sorry, inference. So these things you study in this unit. So I would suggest all the faculty first you teach what is the logic, then what is the reasoning by taking some example, and then what is the inference and types of the inference. The knowledge base consist of the sentences already we have discussed. These sentences are expressed according to the syntax of the representation language. Example, x plus y is equal to 4 is a well formed sentence. Well formed sentence means what? Meaningful, semantics. Whereas, for example, you give the x 4 y plus equal to is not. It is not a well formed sentence. Now, what is the job of logic? A logic must also define the semantics or meaning of the sentence. So just we will proceed this example. The semantics is truth. Semantics define the truth of that sentence with respect to its possible words. For example, the semantics for arithmetic specifies that x plus y is equal to 4 is true in a word where x is a 2 and y is a 2, but false in a word where x is 1, y is 1. Okay, so this is a logically correct sentence. In standard logic, every sentence must be either true or false only. Now, knowledge, uh, representation language, and interference. Now, what is the functions of the long knowledge representation language? It is used to specified by the syntax and semantics. Syntax, the atomic symbols used in the language, same in knowledge base we use some symbolic symbols into the knowledge base agent. So before that, just I would say you there are two types of the AI. One is a symbol based symbol based AI, and second is a connectivist or connection based AI. So symbol based means using the preposition logic and other things, and connectionist AI means you can use the some algorithms such as neural network and other algorithms nowadays, deep learning and support vector machines. So these are the connectionist AI. Normally, symbol based AI is not being used widely. So you all must know most of all faculty how they have completed the PhD using the second one AI. Somebody have used the support vector machine, somebody have used a neural network, and so on. But very less. researchers have done by using the symbolic or symbol based AI. So you can go with this first type of the artificial intelligence also, and you can do the research in this area also. Now coming to the knowledge representation languages, the syntax and semantics specification is very important using the knowledge representation languages. Syntax means means the composition of the meaningful compositions of the symbols, that is called the syntax. Semantics means meaning. Already we have discussed in this example what should be the meaning and what should be the syntax. Now, logic inference or deduction derives the new sentences in the language from the existing ones. So this is the one example. For example, Socrates is a man and all men are mortal. So these are the two sentences. So you can call or you can convert into the symbol Q and P, for example. So what you can do or what can entails Socrates is a mortal. So this is called as the inference. Meaning is that if two symbols are there, by doing the reasoning, you can create the new sentence that is called as the new knowledge. Means I know, for example, Socrates is a man is a one knowledge. All men are mortal is a second knowledge. But or two sentence separately. But by doing reasoning, this is the reasoning process. I can convert into the new sentence, and that sentence is the what is what Socrates is immortal. So this is called as the reasoning, and for doing this there is required thought process, thinking process, rational thinking, or there is required the human thinking. Okay, so this thinking we can introduce into the computer by using this logical agents or knowledge based agents. Now, in this case, proper inference. Okay. So, whatever the result, Socrates is the mortal is a proper inference. Means rational inference should only drive sound conclusions. That is very important. So, we will see what is the sound and complete inferences, all these things in next some slides. But what is the motto of this reasoning or inference? It should be give the sound conclusion. That is very important. Or rational result, rational things. Now in propositional logic syntax, we require the constant, we require the symbols. Okay. Then constant and symbols are atomic. Atomic means what? Atomic means unique. Other sentences are the complex. So in the propositional logic, so to do this reasonings, we use the propositional logic. Try to understand, and we can use the different properties of the propositional logic. For example, if S is a sentence, then you can in bracket S is a sentence. If S and R sentence, then you can conject. You can combine two sentences using the ending. Okay, is called as the conjunction or conjunction operation. You can do ORing, that is called the disjunction. So these are the rules or these are the properties of the propositional logic. Now S implies R means what? S is a premise or incident, and R is called as a consequent, also called as a conclusion or new line, new sentence in terms of the knowledge based agent. Then you can use bidirectional implication, means meaning is that S implies R and R implies yes. So you can use this one also for deduce the new norms. Okay. So this is a negation, okay, which indicate the negative or means negate something. For example, I am doing work. If I negate it, I am not doing work. So that is indicated by this symbol actually, that negation symbol. Literally is an the atomic sentence or the negation. P and negative s or negation of the s is are called as the literal. So this is the fundamental. So I will discuss how these are used for the deductions and all, but I cannot directly start the examples. So basic things first I would like to discuss, and then I will go to some examples. And we can use some operators, that is the negation operators and operators. So these are the operators. So actually the faculty should teach these basic things before starting the exact examples or proper examples, so that student will learn what are these and what is the use of that one. Propositional logic, semantics. So in propositional logic, true and false indicate the truth and falsity in the world. A propositional denote whatever the fixed statement about the word you want, which could be true or false. And the semantic of the complex sentence are derived from the semantics of their part. Their part means basic or some symbols according to the following table. So for example, this is a this table, you know, everybody know this one, which is used for the in the prepositional logic. P and Q are the two sentence, for example. So what is the negation of that? If P and Q are both false, the negation is true. P with negation is a true. Then P and Q is false, P or Q false, P implies Q true. So this table is very important for the deduction purpose. Okay. So faculty or students should know this table, or they can remember for deduction purpose. Okay. Then you can use this exclusive or also by using the this P this P Q. Implication is a material implication. If P is a false, means P implies Q is true by default, and so on. Okay, so this table is very important for the propositional logic. Then you can do the validity of this truth table. Means validity and inference means what? Validity is a very important. Okay, so you should do the validation of the sentence or complex sentence. Okay. An interpretation is an the assignment of the true or false to each atomic propositions. A sentence that is true under any interpretation is a valid, or you know, tautology and analytic sentence. So this doing verifying the tautology of any sentence, and if it is true, you know, that is called the tautology. So this is used for the validation. Then validity can be checked by exhaustively exploring each possible interpretation in the truth table. So validity is also very important. Inference can be performed by the validity checking. First, you have to do the validation and then you have to do the interference. If suppose this is a one example, suppose S1 and S1, S2, Sn are some knowledge, and if you want to conclude C logically follows. So you can write this one S1 and S2 implies C. Okay, and you can check it whether it is correct or not. So that is called the validation. And for that validation, how many in this case, for example, n sentences are there. So to validate this sentence, S1 and S2 dash dash Sn to prove C. So how many rows are required? It is depend on the n values. Means n yes means 2 raised to n are required for the validations. Now what is the model and entailment? These are the basic terminology actually. What is the validation, what is the preposition, what is the semantic, what is the syntax, and then we will see one example. Now what is the model and entailment? The entailment is used to give the relation between a sentence and another sentence that follow from it, and see how this leads to a simple. That is called the entailment. If the sentence is true or interpretation is true, it is called as the model of the sentence. For example, when in Venn diagram you can show the truth value or in truth interpretation using some symbolic representation, that is also called as the model. So these are little bit uh, definitions. Now in this case, a sentence A, so the, in first line, A sentence A entails a sentence B if every model of A is also a model of B. So meaning of this is what? If A is true, then B must be true. Means that is indicated by the equal. A vertical line equal B. What it indicate? Both are same. Both are same means what? Equal. If A is true, then B must be true. The meaning of this. So this is also called the intel. Okay, entailment, and it is indicated by this symbol actually. Vertical line equal to some other operators. Then correct logical inference is characterized by the entailment. Okay, so entailment is a very important, means it is actually representation style in computer. It's called as entailment. Entailment. We want to be able to infer whether a sentence yes follows from a knowledge base. So you can indicate by this. Okay, means if you want to represent whether yes is in KB or not, so you can represent in this way. Okay, if you represent in this way means what? S is in K. Now what are the rules of the in inference? As an alternative to checking all the rows of the truth table, one can use the rules of the inference to draw the conclusion. Okay, by using the logical proof. Now finding a proof, actually we do some validity, then you do the inference, then we do logical proof using this table, these two tables. Okay. Meaning is that finding the logical proof is searching a problem in knowledge based agent by using the knowledge based agent. So this proofing means finding proof is very important in searching problem. Okay. So already we have studied some searching A star algorithm and all. So there is no any finding proof of validation. But in the propositional logic, we have to find the proof of new sentence, how it create, and proofing this is called as the searching. Okay, with the inference rules, by using the some inference rules. Means in nutshell, this propositional logic can use for the searching purpose, but the approach of searching is different. What is the searching approach? Finding a proof by validation, by inference. Okay, by using the inference rules, and this is called the logical agent. So this is the work of the logical agent, and this is the difference between the problem based searching and logical agent based searching. So logical inference can be more efficient than the truth table constructions. Now these are the some rules of inference. So there are 5 6 rules of the inference. One is the in means all you can call these rules as the entailment examples. So first rule is modus ponens. Meaning of this inference rule is that if alpha implies B is a one sentence, for example, in database, and there is alpha, alpha implies B, and there is a one alpha, means the two sentences are there. Now, what is if you do the reasoning, means if alpha is there, beta is there, and alpha is in database, meaning is what? What is the meaning? Definitely beta is in also in knowledge base or database. So this type of the rule is called as the modus ponens, or it can be represented by this entailment symbol, or you can represent in this second form also. So normally in our basic subjects or discrete mathematics, you might have seen the second style of writing. Okay, but if you use this, that is called the entailment. Then second rule is the elimination. So what it say, if alpha and beta is there, okay, or alpha, if you do the ending of alpha and beta, it implies or it deduce alpha only, okay, or alpha and beta, it can deduce beta, both are same. That is called the elimination method. So one sentence is eliminated and second is taken. Then and introduction, if alpha and beta, it entails alpha, not that one, in bracket alpha comma beta, that entails alpha and beta, that is called the introduction. Introduction means what? You are introducing and. So this is a rule, and we use these all rules for the new deduction, new creations of the sentence using sentence. So meaning is that suppose alpha is one sentence and second beta is also sentence. So what you and it is in database. So you can combine it. That is called the introduction by using the AND gate. Or introduction means you can introduce the or. If alpha, then alpha or beta, or if beta, then you can write the beta or alpha and so on. Double negation means what? If the sentence is indicated by the double negation, that will convert into the positive, means minus into minus positive in this way. That is called the double negation elimination. Implication, if alpha implies beta, that indicate not alpha, negation alpha means not alpha or beta. So that is the deduction actually. So this is the rule. Then unit resolution, if alpha or beta is there and negation of beta is there, means not b is there, meaning is that alpha is there only. So it not beta means beta you can remove. Alpha or beta and not beta means what? Alpha. So that is called the unit resolution. Then only resolution, which is the very important in the inference and doing the deduction resolution. So what is the what is this rule says? If alpha or beta and not beta or gamma, okay, so these two sentences, combination of sentences are there in database, meaning is that you can deduce that alpha or gamma, because so see here, alpha or beta, but beta is not there, means what? Means beta,
Nothing
this
else.
positive beta and negative beta will minus, definitely only alpha and gamma will be there. So that is called the resolution rule of the inference, and these rules are used for the deduction purpose. So take this example. If John is not married and he is a bachelor, it is indicated by the not p, means p is he is married, and not p means he is not married. Okay, means not p implies q, meaning is that if John is not married, he is a bachelor. Where John is not a bachelor means not q, and he is a married p. And if this sentence is given, so what will the result of that? If you do the validation and proof, So what will the output? Output will be P. Okay, so how it is? So see here, not P implies Q means you can do the negation, implication. Okay, so using the first rule, that is implication elimination, if alpha implies beta, you can write the negative alpha or beta. So here it is written. Okay, means negation and one negation means double negation. So you can use the second rule, that is called the double negation, means definitely it will be the P or Q. Okay, now if you see the sentence, first sentence, P or Q will not be there, means it is not implicated. So what you have to add? Not Q. Okay, and if there is a P Q comma not Q, means you can write the P. So see the unit resolution. So this rule, unit resolution. If alpha or beta and not beta, then alpha. So meaning of this P or Q and not Q means P, means unit resolution. You can use this one. Okay, means what? P is what? He is not married. He is married. Now this you can verify, validate by using this table, this one table. That is validation proof table. Okay, and if it is true, means P is there by using the modus tollens reasoning. Okay, so this kind of deduction you can implement in computer by using the proportional logic. Then satisfiability and complexity of the inference. A sentence is satisfiable if it is true under some interpretation. Means it has a model. What is the model? We already discussed. The model is that if the truth value of any sentence is true, then and then it is called as the model. Okay. And what the first sentence? A sentence is satisfiable if it is a true. Means what? It has a model. Otherwise, the sentence is unsatisfiable. A sentence is a valid, means we require the validation if and only if its negation is unsatisfiable. So all these rules you have to implement in computer. Algorithm for either validity or satisfiability checking are useful for the logical inference. And this logical inference is the job of logical agent or rational agent, I would say. But that programmer should know what is the validation and what is the unsatisfiability, what is the satisfiability. Are you getting? So both things you have to do. But doing both is also very difficult. Means you can do validations or satisfiability checking. In propositional logic, in symbolic logic, I would say, validity must enumerate 2 raised to n rows. So already this is the answer of this question actually. How many row do you need to check this S1 and S2 implies yes. Okay, so already I said 2 raised to n rows are required for checking the validity of this example. Okay, now satisfiability and complexity of the inference. How proportional logic satisfiability is the first problem to be NP complete. Satisfiability, checking of satisfiability is a very difficult, or it is the NP type problem, NP complete problem, and therefore it is assumed to be no polynomial time algorithm. You know what is the NP complete program or problem which cannot be solved in the polynomial time. That is called the NP. And satisfiability checking is a NP complete problem. Therefore, sound and complete logical inference in the propositional logic is intractable in general. Tractable and intractable. Tractable means solvable problem. So both you cannot do. Already we have discussed sound and complete logical inference is very difficult. Okay, it sometimes it may be sound, may not be complete. Sometimes it may be complete, may not be sound. Okay, so this is actually NP complete problem. Now coming to the first order logic, though, so still now we have discussed the basic things or the rule means inference and rules of the inference. Now actually we will study how the propositional logic can convert into the predicate logic, or how the predicate logic is useful. So there are some drawbacks of the propositional logic. So uh, the propositional logic, each possible atomic fact require a separate unique symbols. So this is the drawback. If there are n people, for example, and m locations, so the complexity will be n m raised to 2. Okay, means these symbols means n m raised to 2 symbols are required, and that will be the very big system, and it is very difficult to handle all these symbols. So this is the main drawback of the propositional logic. Whereas predicate logic include the ontology. Am I audible? Just for checking.
Yes, sir, you're audible, sir.
So how much time?
Sir, I half an hour is remaining, sir.
Yes, yes. I will try to finish. Okay.
Yes,
Then
sir.
ontology is a regress. So what is the ontology? Means predicate logic depend on the ontology, or it is it include the richer ontology. Ontology a regress and exhaustive organizations of sub knowledge domain that is usually hierarchical and contain all the relevant entities and their relation, that is called as the ontology. And this ontology can be used in predicate logic. So predicate logic consists of the objects, properties, relations, and function. Okay. Then it consists of the constant, for example, block 1 and block John. These are the constant name or any variables. Function symbol, for example, father of successor or plus and so on. So these are the functional symbols. Then propositions are represented by the predicate applied to the tuple of the terms. So terms are what? Terms may be objects in the predicate logic. Predicate represent the property of or relation between the terms that can be true or false. That is called the predicate. So see this example: John is a brother of Ray. Then square one is left on the square. So in this case, brother and left off are the predicate, or plus one, 1 plus 1, comma 0 plus 1. These are the functions. Okay, and these two functions are predicate by using the greater than. So when these two functions execute, so which is the greater value, it is indicated by the this predicate. So greater than is a predicate. Now propositions are represented by the predicate. Already we have discussed. A predicate represent a property of or relations between the terms that can be true or false. For example, John is a brother of Fred. Square 1 is left of the square 2, and so on. So these are the example of the predicates. Now this is the syntax of first order logic. Sentence, atomic sentence. Sentence implies atomic sentence. The sentence, conjunctive sentence, we use the quantifier, we use the negation of the sentence, then we use the bracket in bracket sentence, then atomic sentence. Okay, use the predicates, then terms. Okay, then constant, variable, connectivity, quantifiers, constant, variable, predicate, function. So this is like a grammar of any language. So you might have studied in TOC. So we write the grammar in this way, means by using the variables, and we can convert that variables in fixed notations like that. So this is the syntax for the first logic using some languages. Okay, sentence in first logic is what? An atomic sentence is simply a predicate applied to a set of terms. For example, John owns car 1. John sold car 1 to Fred in this way. Okay, so you can use, so this is the one sentence. Okay, by using the predicate. So owns and solds are the predicate. Okay, and like this, like these predicate and some constant, we can say it as a sentence. Semantics is what? It is true or false. And we can use the connector as or, negate, and so on. Semantics, same as in propositional logic. Now see here, John owns car 1 or Fred owns car 1. Okay. So these are the two sentences. John owns car 1 is a one sentence. Second, Fred owns car 1 is a second function. It is ORing. So what is the meaning of this? John sold car 1 to Fred. Or, okay, so John do not own car 1. Are you getting? Because after solding, the car 1 become of the Fred. And this is a meaningful semantics actually. So such type of the logic or reasoning is used into the first order logic. We can use the quantifier, universal quantifier. You know the universal quantifier. Okay, means all x. For example, all x loves FOPC, means first logic programming. X are all x are whales, implies all x mammals and so on. That is called as the universal quantifier. Then existential quantifier we can use. And how to use the quantifier? These are some example. All x are whales and all x are mammals using the and operator. Okay, it says that everything in the universe is both a whale and a mammal. Like these examples, we can take the example of existence also, or existential quantification. Means there are some x, okay, some x, or at least one x. Means Mary owns at least one x, where x is a cat. Means what? One cat, or at least one cat owns by the Mary. So these are the deduction or meaning of these sentences which are used into the propositional logic. Then you can use the quantifier, nesting quantifier. For example, in these both cases, both x and y are universal quantifier have used here, and x and y you can, or you can do the any combination. Then so this is a variable scope. Okay, so you can replace the variable by the sound variable. Okay, so rational between the quantifiers, universal and extensial quantifications are logically related to each other by using this different rules. You can use these rules for the deduction purpose. Okay, so there are many rules. Equality, if x and y is equated in last, so meaning is that Mary owns two cats. Inequality needs to ensure x and y and are the distinct. So this is used for both sentence are same. So equality you can use. Higher order logic can use or it allows quantifier to range over the predicates and functions as well, whereas first order logic can use for the objects only, not a function, not a relations, and so on. So these are uh, difference between the second order and first order logic. Then logical KB means knowledge base. So we use the axioms describe the relation between the predicates and the definitions of the predicates using the this bidirectional implication. Okay, so in this way we can represent the knowledge into the KB. Now coming to the inference, there are different type of the inferences. One is a forward chaining, backward chaining, and resolution reputations. And that is why in first slide I said resolution reputation is very important, because in inference mechanism, resolution reputation do the better than the forward chaining. So these are three styles, or I can say kinds of the inference: forward chaining and backward chaining. So directly we will go to the forward chaining and backward chaining. So before that, properties of the inference procedures or entails is the soundness and completeness. Now what is the soundness? Soundness means if A entails B, means what? If A then B asserts that if A is true, then B must be also true. Or then A entails equal to B means A is equal to B. So that should be there. Both, if they both things are validated, then it is called as the sound inference. What is the completeness? If A entails equal to B, A is equal to B, then A entails B means if A then B asserts that if A is true, then B must be true. Now forward and backward chaining are sound and can be reasonably efficient but are incomplete. Resolution is sound and complete. That is why resolution is very important. So I have given the definition of soundness and completeness. And actually, this definition should be defined in this way, not just using the simple language. So it should be tell in Intel form. Now inference rules for the quantifiers. What are the rules? There is required the substitution. Alpha is the substitution, means denote the results of applying a substitution, means variable should be substituted by the real value, or real value can substitute by the variable. So if you do the things in forward, so what we do, we substitute variable by the real value or real sentence. That is called the forward in means forward chaining method. And if you replace the real by the real sentence by the variable sentence, that is called as the backward chain. Okay, so these rules must be followed. Universal elimination rule means in this case v all v where v is a variable and alpha is a sentence and g is a ground term. Ground term means real terms, real sentence. Okay, so for example, see here, you in universal elimination, x loves, okay, all x loves FOPC, it implies ray loves FOC. Here ray is a real or ground term, x is a variable, okay, and alpha is a sentence. In this case, FOC FOPC is alpha. So what is here actually? So this is called as a universal elimination, means this x is replaced by the real or ground term. So this is called the universal elimination, means all. Extensial elimination means what? This same thing is there, but some x must be replaced by the real or ground terms. So see this example. Suppose Mary owns X and cat is a X. X is a cat. It implies Mary owns Mary cat. Means what? This X is replaced by the Mary cat. Okay, Mary cat is what? It is the name of that actually cat. But X is cat is replaced by the Mary cat. Mary cat is a one, not a many, not all. Means exist. There is a Mary cat. a- There is a existence of Mary cat whose which is belongs to the Mary. Okay, so that is called as the existence elimination. So this elimination you can use into the forward chaining or backward chaining. The
Excuse me,
existential
sir.
introduction. Yes,
Sorry to interrupt. Sir, 10 minutes are remaining.
yes. I will try to finish. Okay, so
Thank
this
you.
inference rules for the qualifiers are required. So this is the one example. For example, all x and y means x is a parent of y and x is male, then x is a father of y. Okay, or it can replaced by the very means real term, that is Tom and John, means Tom is a parent of John. So this is called as the forward chaining. Okay, then we can use the generalize the modulus ponens, then canonical form for the chaining. Then unification you can do into the backward chaining. Unification means what? Unify means it is used for backward direction. Means this is the uh, means reverse order, for example. So unify P and Q, take two atomic sentence and returns a substitution that makes them equivalent. So for example, unify P and Q is equal to Q. So P and Q are replaced by the this sorry theta. So that is called the unify. Means there is a unification. So example is this x and y. So you unified by means x and y is unified means x can replace by the Tom and y can replace by the John, or reverse one. John can replace by the x and John can replace by the y. So both things you can do. Okay. So actually unifications are used to do the both back chaining and resolution in inference. Okay. So these are examples. So what is the forward chaining inference? It use the module ponens to always derive all the consequences from the new information. It prevent the additions of the sentences and it must have the horn clauses. Okay. So this is the algorithm for the forward chaining. So this is the one example of forward chaining. In this x and y is replaced by the John, Tom and John. That is called the forward chaining. This is the example. Now what is the problem with the forward chaining? It sometimes it can exploit forward and may not terminate. For example, take this example, x is even implies x plus 2 even, integer x means 2 times x is
त्याच्यातून
even,
पिंक कलर आहे बघा
and x
आबोली
is
कलर
even implies
बाहेर
integer,
जेवायला
and it is a never ending thing. So this is the drawback of the forward chain. Now to overcome this problem means drawback of the forward chaining, what we do, we use the reverse procedure. You ask the query to the KB and we conclude the result. For example, x is siblings of the John. Is it correct or not? You can verify by replacing this formula now. Which one? Unification formula. Okay. So you have to see whether x and John are siblings or not, or x is father or y of the y. So this is one example. See here, x is parent of y, male, and same thing. And in this case, Tom is a male. Okay. Query is what? The whether Tom is a parent of x. Now you have to see x is a real son or not. by replacing the X by John and X friend, and both are things are correct. So what will the output? It will be the true. Okay. So in this way, backtracking is happen. Resolution references, inferences. Again, we use the unification using the different rules or norms. You can use the conjunctive norm forms for the resolution inferences. So actually, this is a combination. CNF means conjunctive normal form is a combination of both conjunctive means conjunction symbol and disjunction symbols. Okay. Now coming to the planning. So hello.
Yes, sir.
So I
Yes,
just required more 10 times to finish the planning, because it is I want to uh, actually I wanted to describe in detail, but due to the time I cannot do
Yes,
that.
sir.
But
Actually, we are
I
from
will
the
just
time constraint.
touch to the
Yes.
planning, and I need only 5 10 minutes if
Oh,
you
okay.
allowed me.
Yeah, yes, sir. Sure. We have 5 minutes. You can
Yeah,
please.
ठीक.
Yes. Thank you.
So I need more 10 minutes only.
Okay, sir. Okay.
Okay. So we have defined what is the planning actually. We have defined AI as the study of the rational action, which means that planning. Rational action means what? Planning is required, means devising a plan for action to achieve the one's goal. Okay. Now the problem solving agent of searching can find the sequence of actions that result in the goal, but it deals with atomic representation of the state, and thus needs a good domain specific heuristic is required. Now in planning, we do not use the domain specific heuristic. We use the independent domain independent heuristic. That is the main difference. Means what? We use the ground variables. Okay, in the planning. Now planning is a particular type of the problem solving in which actions and goals are declaratively specified in logic and generally concern performing actions in the real world. Okay, so this is the planning. For example, opening up the representation of the state goals and actions, a planner can make more direct connection between them, states goal and actions. So this is the example of the planning. So and this is a type of the divide and conquer method. Okay, so by doing the divide and conquer, so big problem can be solved using the planning. And for that we use the language that is called as the planning domain definition language. Okay, and in this language, or this language can describe four things: initial state, the action that are second four means four things. Okay, so one is initial state, then action that are available in the state, the result of applying an action, the goal state, and so on. Okay, so these four things are done. Now fluent in planning is very important. What is the fluent? Each state is represented as a conjunction of the fluents that are ground, real, and functionless. That is called as fluent. But in artificial intelligence, a fluent is a condition that can change over time. Okay, actually planning consists of the fluent. And what is the fluent? It is the condition, but it is that condition may be changed over time. In logical approaches to reasoning about the actions, fluents can be represented in first order logic by predicates having an argument that depend on the time. For example, the box is on the table. If it is, if it can change over time, cannot be represented by just on box on table. Means this predicate. So what is required? There is required the time. Okay, because it is a planning is a consist of the fluent. It is not a just sentences. So this is the difference between the knowledge based agent and planning. Okay, so in planning there is require the time. Okay, means actually predicate should be with the time. For example, see here, on box on table is not a fluent, it is just a predicate. We can use into the propositional logic, but in planning third atom should be add, that is called the time. Means what, you can write in this way, box is on table at time t, means that box is on table at time t. Okay, but in next time or t is equal to t plus 1, the box may not be on the table. Okay, that is called as the fluent. Okay, so this representation of the fluent is modified in the situation calculus. Means if the environment get changed, it is changed, and this is actually called as a logic agent. I had given the example of taxi driver. Okay, so this he can do the planning. Okay, but in computer you can do the planning using the PDDL. Okay, now a fluent can also be represented by the function. Okay, but you can you have to use the means predicate also. So see here, on box table you can convert into the means function, but function, okay, the function is just for execution purpose, but predication is required, so you have to add the predicate. So this is the example, on box table comma t, and we add the holds at, means table means on table there is a box at time t, when it is possible, when hold at get executed, otherwise not. Means they, if there is some action, then and then computer will decide whether the box is on the table or not. Okay, means it is the combination of function as well as predicate. Okay, so this is and this technique is used into the planning. So actually I don't have the time, but I will try to uh, cover one example. The following fluents are not, means uh, means non-ground is not required, variable is not allowed, then not means negation is not allowed, and in this case Fred is a father and in Sydney. So the means which is in Sydney, it is not also allowed. Yeah, means there is require the execution of complete function. There is required the action schema in the planning. Action schema is a schema which decide the next action. So which next action should be there, that will be decided by the action schema. So see this example, this is the action schema. So for example, in this case, suppose one plan is flying from one location to another location. Okay, and you have to indicate by, or you have to execute, or you have to write into the artificial intelligence term. Okay, so schema is lifted representation. It lifts the level of reasoning from the propositional logic to a restricted subset of first order logic. Okay, so for example here, the it is the action schema for flying a plane from one location to the another. Okay, so this is the syntax of action schema into the planning, which you can write into the PDDL language. So action fly p from to, meaning is that p fly from to. This is the action. Precondition is what? It is precondition is one process and effect is process. Okay, so these three things are required into the planning language. Now, what is the precondition in this case? Precondition define the state in which the action can be executed, but not may not be. Okay, effect is what? Execution means action is completed. That is called the execution, and output. It means if you want to indicate the result, that is indicated by the effect. Okay, so these three things are required to uh, do some operations. Means action is what? Action, then precondition means possibility, and actually exact output. So these things are required. Okay. So uh, I will
Sir.
take one example, very last. I think this is the last example. Suppose I
Okay,
want
sir.
to write the program or the PDDL, means programming language, describe of an air cargo transportation planning problem, for example. So this means one plane carry cargo from one location to the another, and for that purpose I have to write the program or implement into the artificial intelligence by using the PDDL. So this is the overall means complete program. It must be start. Hello.
Yes, sir. Yes, sir. You're audible.
Yes. So it should be start from the unit. Okay, C1 at SFO, means C1 is a cargo at SFO, and C2 is at JFK. So these are the location, SFO and JFO are locations. And P1 at SFO, it may be the San Francisco. I don't know what is the meaning of that, but you consider that is the location. P2 at the JFK, and cargo C1 is cargo, C2 is cargo, P1 is plane, P2 is plane. Okay, JFK is the airport, name of the airport. SFO is also name of port. What is the goal? C1 should add the JFK and C2 should add the SFO. This is the goal. What is the action? Okay, so first there is required the loading of the cargo in plane, and then unloading, and then flying. Okay, so these three things are required into the this example. So first action is what? Load. CPA, where C is cargo, P is a plan, A is the airport. Okay, now precondition. In precondition, C at A means cargo on airport A, P plan is at airport A, C is cargo, P is plane. Okay, airport is a A. It is for the A airport. Effect is what? C at A and C means cargo in P. This is the effect. In loading, unloading means what? Same thing. Precondition means maybe. Precondition is what? It is the probable condition. C in P, in unloading, what is the C is precondition. Okay. C is P plan and P is at airport. C is where? C is cargo, P is a plane, A is a airport, and effect is what? C at A means cargo is at A, but what should be there? C should not be in plane, means that is called the unloading. Okay. Now action is what? P fly, where fly is action in our case. P fly from to. Precondition is what? P is at from, is any from is replaced by JFK, or from where plane fly. That is called the from. Then P is a plane, from is airport. Okay, and to is also airport. It's name of the airport. Effect is what? P at P at from. P at from means it start the flying. And P at to, meaning is what? Plan is reached to the to destination. Okay. So this is a very important program which can return into the PDDL using the planning. This is very important. Now, second example, already all faculty must have known. So this is a starting state, and we require the
Excuse me,
last
sir.
goal A, B, C. Yes,
I'm extremely sorry, sir. Actually, we are
एकच minute.
really out of.
Last,
Okay,
last,
okay,
last, sir. Last.
okay.
Okay. So this is a planning example, and you can write this movement of the box from one table to another table in this way. That is the in last goal. So you can write this program. You can use the deductive planning and all, okay, by using the this predications, okay. And thank you. This is my last slide, and sorry for taking more time, which is allocated for me. Thank you very much.
Thank
Yes,
you
sir. Thank
so
you very
very
much.
much. Yes, so that was very detailed presentation, and I'm sure all the faculties will hugely admire your presentation, sir. Thank you so much for taking the efforts to explain in such detail and wonderfully with all the examples. Quickly moving
Thank you,
forward,
sir. Thank you.
with the last session of our day, which will be conducted by Dr. Parikshit Mahale sir. He'll be our next honorable speaker for the day, who will guide us through the topic of artificial intelligence and its future perspective. So, just a brief introduction about him, that he's currently working as a professor and HOD of artificial intelligence and data science at VIIT Pune. And he's also a proud holder of a BE MTech degree along with PhD in wireless communication from Aalborg University, Aalborg, Denmark. Then he has an experience of over 21 years and total publications that include journal, conference, book chapters. It's over 190, and number of Scopus publication is over 100, and he has received over 975 citations up till now. Along with this, he has also filed a 9 plus patents till date. He has authored over 20 books on subjects, along with major contribution in another 7 books. He has coordinated many workshops and has been invited as an honored speaker at a number of conference and events. He then with an impressive CE of over 40 pages. I really doubt that I can even remotely cover his achievements and the number of awards and recognition which he has received till date in his career. So without taking much more time, I would like to call upon Dr. Parikshit Mahale sir to kindly take forward the forum, sir. Just one second before that, I kindly request. Yeah, okay, okay. Yes, please, Dr. Parikshit Mahale sir, please. I welcome you, sir.
I hope I am audible.
Yes, sir.
Yes, sir.
Yes,
You're
sir. Good
complete.
afternoon, sir, and welcome.
Thank you, thank you. Very good afternoon to all. And first of all, let me congratulate Bharati Vidyapeeth College of Engineering, Lovely Campus, Dr. Uday Patkar and his entire team for hosting this first faculty development program in association with Board of Studies Computer Engineering on this very interesting subject, that is artificial intelligence, which is there in third year, second semester. Equally, I would also like to congratulate all the teachers, basically those who are attending this faculty development program, even on the digital platform, and decided to accept this very interesting challenge to teach this subject, artificial intelligence, to all the students on 100%, at least for this semester, on online platform. Uh, when I was discussing with Dr. Uday Patkar sir regarding what I will cover in this session, and then I thought that let me give you all some insights that what AI we were taught, what AI we are going to teach, and what AI our students going to take ahead. So let us take a brief discussion on this, maybe for 20-25 minutes, and I'm very sure that you all will have a good insight on what I'm going to discuss. My request to all the teachers, those my request to all the teachers, those who are attending this faculty development program today, is when we talk about artificial intelligence, in this year 2022, and I don't know how many of you learned this subject when you was doing your engineering at maybe in computer engineering branch, in maybe information technology branch. Maybe for some of the tenure of even computer engineering and information technology, this subject was sometime elective. Sometime this subject was then converted from elective to compulsory subject, and now again we have this subject as a compulsory subject in third year. So what is important is, when we talk about this artificial intelligence as a bigger picture, my request to all the faculty is to, please discuss every unit, every topic in the subject with the use case, which is basically in line with the, this AI driven world. So please let me share my few slides with you. And sir, please confirm whether my slides are visible or not. So
Yes,
I
sir.
hope my slide
Your
is visible.
slides are visible. Yes, sir.
Okay, so I'm going to walk you through not more than 6 to 7 slides. Don't worry. But let us try to understand what is going in and around, because definitely if you will start this subject in for this semester with the students, they all know what is artificial intelligence, because many of your students have already started working in AI and allied components of AI, that is machine learning, deep learning and data science, and eventually what is coming up is cognitive computing and so on. So, what is important is, let us go back and, before 20 years. And if I will ask you a very simple question, please feel free to, answer my question that, or maybe, let me take your small quiz. And can anybody tell me when this artificial intelligence was coined long back? Is it a new branch, or it is a traditional branch which is coming over the years? Anyone? You can unmute yourself and answer my question, or maybe you can put your responses in the chat box, please. Yes.
Sir, artificial intelligence. It was a subject when I am in the Amravati
Engineering.
University.
Yes.
It was an
Yes. Yes.
artificial intelligence
So
subject.
definitely,
So
yeah,
it is a
definitely.
tradition.
Yeah, definitely, Anuradha madam. It must be in 90s. This subject was there when you was doing engineering, or maybe in early 2000, right? Yes or no?
Yes,
So definitely
yes,
artificial
sir.
intelligence. Yes. So definitely artificial intelligence is not the new subject. This is first thing everyone should take a note of this, and that is what my plan is to take you ahead from this discussion, so that you will understand what has been transformed for this particular subject, and now where this subject is going to lead for next at least 2 decades. Is it fine? So that's very good answer. So let me walk you through the very interesting word. And what is first point is, every individual, every teacher and every student dealing with this subject should be able to differentiate between the artificial intelligence and natural intelligence. What is the basic difference? Everyone should understand, and that is what is entire world is moving towards. Even there is a natural intelligence in place, we are now marching towards AI driven application, where we are interested to impart intelligence artificially. Are you agree with me? So definitely, what is the reason? Anybody? In spite of having natural intelligence, abundant of natural intelligence is available on the earth, still we are going for an integrated application where we are interested to impart this intelligence artificially, right? Are you agree with me? Yes or no? So my question
Yes,
is
sir.
why? My question is why we are going towards this trend of imparting this intelligence artificially. Answer is very simple, but I would be happy if it comes from you. Anyone?
Sir,
Anyone?
according to my point of view, robot it is an example of artificial intelligence, and human being natural means human being doing some task, that is natural intelligence. And your question is that why it is required, means for the technical improvement or for the progress in the country, we have required a manpower in everywhere, so that without using more manpower we are using a robot. That is the example of an artificial intelligence. One little boy can laugh, one little boy can cry, and nowadays robot can also cry, robot can also make tone voice and etc.
Okay, so the simple reason, the simple answer to this question is, we are 80. Vanita madam, please mute yourself. Okay, so the reason is, it is very simple reason that, we are now looking forward to design and develop application where we are interested to replace human being by machine. I hope you all are agree with me. So please understand the main philosophy that we are interested to replace human being by machine in all the use cases surrounding to us. And when we are replacing human being by machine, we want to impart this intelligence artificially into the machine. And that's the reason, this word AI is now again coming into the picture. So now let us try to understand, I hope my slide is moving.
Yes, sir. Yes.
Yes, thank you so much. So, this slide talks you, lot many things. The first is, it is a basic branch of computer science, and I don't know how many of you are aware, but this branch, this word, and this particular subject was coined long back in 1956 as one of the core branches of computer science or computer engineering. Is it clear? So, and that we call it as artificial intelligence. But now, my question will be to you all that, what is that difference when, in the AI which we learn and, we have been taught in 90s, and the AI which we are dealing today. Anybody? So I hope my question is clear to you all, that, this should be very clear. And then eventually we'll go to the few more terms, and then maybe we'll have some question answers if possible, and then maybe we'll conclude. So my question is, what is the difference in the AI which we have been taught or we learn in 90s, and the AI which we are going to deal in 2022? Anybody? Please feel free to express yourself. Don't worry, your answer can be wrong, doesn't matter, but we all are here to learn. Is it fine? So what is a transformation which took place? The word is same, right? Ultimately the philosophy, ultimately the objectives are going to be same, but notion of the subject is completely changed. Is it clear? So anybody would like to comment on this? Anybody? My question is very simple. What is the change in the AI which, between this 30 years or maybe between this 20 years of span, what is change in the artificial intelligence? Anyone? Come on, please feel free to answer, so that, it would be a good discussion between all of us, and there will be more takeaways. Anyone?
Hello, sir. Good
Yes,
evening.
yes.
This is
Good
Mohit
evening.
Amkar from RMD COE.
Yes.
Sir, actually, as per what I studied, I conclude that initially the information that were means the areas that we were using and implementing into the AI means initially we were working on some certain kind of information. Now we are working on sentiment analysis. Previously we are working on some particular input and output comparison of it, clustering of some amount of data. Now
Correct.
we are
Correct.
digging big we are implementing it on big data. So these are the differences that is there.
Okay, very good.
Hello,
Yeah, somebody is raising the hand. Please. Yes, sir.
hello.
Yes, sir. Please.
Sir, this is Professor Dakne from SND College of Engineering.
Yes, sir. Please continue.
Sir, according to me, the now as you said in the 1956 only this branch get
Yes.
evolved, But the reason behind the nowadays it is getting too popular, the reason is the kind of what you can say, as you know, the machine learning and the deep learning are the subset of artificial intelligence. Means if you want the artificial intelligence to be succeed, these two things are important, and for these two things to be succeed, the data is very important.
Very good.
And in that period, the kind of data availability was not there. So nowadays we have the huge amount of data from these.
Very good.
That is the reason.
Very good. So let's have a big round of applause for Professor Dakne. And sir is absolutely correct, and that is what I request all the teachers to convey this to the students, and this is the right platform of faculty development program. So Notion was not data in 90s, and when we learn. At that time, data was not there. Forget about data, even that was there. That was very small data. But today, the entire notion of artificial intelligence is on data mining and data science. Is it fine? So that's the reason, this point is very important, because, if you look into the AI book which was there and now which has been revised today, and even the objective was that at that time to impart, decision support system, maybe if then else rules. I hope you remember we were doing list programming, so that we can have some kind of artificial intelligence into the existing mechanical operation. That was the objective at that time. Is it fine? But today the notion of AI is completely changed. And now, friends, please take a note of this, that we are not only restricted to AI now. There is
different experiential learning are there. For example, first, pro and cron grid. Okay, so here means the topic, suppose, which is having say, what is the difference between?
Please unmute this faculty.
Done, sir.
Yes. Yeah. So, what is important is, there are many things which are coming beyond AI, and that is what we will see in next 2-3 minutes. So, some examples are given, like spam email, filtration, the classification, as one madam has rightly answered, that, there is a problem of clustering. That is fine. But what is important is where this AI is heading now. So this is the main slide, which you will there are a lot of takeaways from this slide. And basically, what is our objective? Our objective is to now replace human by machine, machines. And when our objective is to replace human by machine, there are lots of challenges. And what are the challenges? That is what we are going to teach to our students in this subject, artificial intelligence, because it's a very vast administrative domain, I would say. Because in AI we have machine learning as a major subset of AI, then we have deep learning as another subset of machine learning and artificial intelligence, and now an integration of this AI, ML and DL coming together is now coming up with new field, that is data science. And there is something beyond data science, which is we are getting into now eventually cognitive computing as well as cognitive sciences. Is it fine? So let me just play a small video. Let me know whether this video is visible to you all, and that video will tell you that what is beyond AI now. So please tell me, sir, my video is being played or not.
Yes, sir. It's loading,
Yes.
sir.
Yeah, it's loading now.
Yes, sir.
Yes, yeah. So
Yes,
it's a
sir.
very short video, but I want you to read this video. I want you to understand, because that is what is our responsibility. We have to let the student know that what is there beyond AI, which is coming up when they will pass out after 1 or 1.5 years, right from today. They are not going to deal simply with artificial intelligence, but they are going to deal with some different flavor of AI. So please, please let me know it is playing.
Yes, sir.
Yes, sir.
Hello, sir.
Yeah, no
Hello,
sound.
sir.
Yes.
Sound is not audible
Yes.
actually.
Yes, sound is not audible because there are some settings. So let us not spend time on this. Now you can just read the messages and what is being played. No problem.
Okay.
I don't know how many of you have heard about this term narrow AI, but the next paradigm, basically the immediate extension of what AI we are learning now is going to be narrow AI. So you should know what is narrow AI, what it is talking about, and there are many more AIs which are coming up. So there is a difference between general AI and the next trend in AI which are coming up, that is narrow AI is one of the immediate trend in AI which is coming up, and along with narrow AI there is another interesting AI which is coming up, that is explainable AI. Let me tell you, the world is now moving towards explainable AI and application of explainable AI in agriculture, application of explainable AI in preventive healthcare. So these are very interesting areas which are coming up, and in my opinion, as a teacher for this particular subject, please link all these 6 units to this emerging trends somewhere, so that it would be more interesting, and it would be great teaching and learning experience for all of us. Please continue. Okay, so I don't know how many of you have really enjoyed this video, but I hope, am I audible?
Yes, sir. Yes.
Okay, so going ahead with so this is what is important message from this, and short video which I have played, that now our entire discussion should not be restricted to the basic AI. Yes, basic AI is really very important for building this entire fundamental and groundwork, but please link every aspect, every topic of AI to the narrow AI which is coming up, along with the several applications, as well as as I already discussed, explainable AI is really coming up. Trusted AI is also coming up now. As you know, I don't know how many of you have heard about federated learning. Do you have how many of you heard about this term federated learning? So federated learning is one of the very important component which would be required for artificial intelligence applications to ensure privacy aware artificial intelligence as well as trusted artificial intelligence. Is it fine? So there are many, that's very good. So there are many use cases which are available. Don't I will not take more than 5 minutes now. So when we talk about this AI driven learning, students should be made very clear that why we require learning, in which situation we want computers to learn, why we want computers to learn, and then the next point is definitely how we should make computers to learn through these AI techniques and algorithms. But eventually, what is important in my opinion, that unless and until you do not relate it with some live use case, maybe from any of the domain, it would not be really clear to the student, because fortunately or unfortunately, whatever you take it as, students have learned AI lot in last couple of years due to this pandemic period. They definitely completed lot many course on basic AI. So definitely our responsibility is going to be more. And you know that is what, one simple example I'm discussing here, that how this AI is, moving towards the growth of big data. Today, whatever AI techniques and machine learning algorithms and deep learning algorithms we are learning, they are there in the literature. Definitely, they are going to be absolute in next 5 years. Trust me. You will remember me after 5 to 7 years. You will never. You all will find that machine learning will get absolute, and something will replace by machine. It's already deep learning is replacing machine learning, and even in the due course of time, you will witness that deep learning is also will get absolute eventually, and something will be replaced, this deep learning paradigm. So what is important here is, always every topic, I'm very sure that you had a wonderful day since morning 9 o'clock, with lot of deliberations and discussion through different experts dealing with different units. But what is important is case studies, by taking some such example, that for AI, for what, because AI does not go alone. AI always goes with some use case, and AI sometimes goes with for detection, AI goes for prediction, AI goes for recommendation, AI goes for decision, AI goes for learning. So it's a very interesting point, and applications are very, very important. Please make students aware about what are basic data science roles which comes under the AI, because they should have very clear picture that data science is not something what we have been doing from generating the data to deploying your model. But basically, when we talk about AI as a bigger picture, there are three different roles, that is data analyst, data scientist, and business intelligence developer. So it is our responsibility to make the students very clear about what are different roles in data science, what is basically a learning. When we talk about subset of artificial intelligence, when we talk about learning, sometime AI application is built to take care of these 6 operations, that is decision, learning, prediction, recognition, analyzing, and remembering. And then your student can also ask you the question that what will happen if machines will be replaced by humans will replace by machine, but there is no alternative to the natural intelligence. Don't forget that human is only there to program the machine. And what is important is, we should understand what is inside machine. As you know that AI has entered into almost every vertical of our daily life, right from entertainment to healthcare to agriculture and so on. So as somebody has rightly mentioned, that the focus and the entire notion of this AI today should be focused around data, because that is what is the main reason, as some rightly mentioned, that it was coined long back 1956. But why it is so famous today? And it is famous only and only due to this growing data. And as you know, this slide is very much familiar to you, but this is the reason. This is the reason that only AI will not be sufficient now. What will be sufficient now? AI with explanation. Because even the measure of big data will grow like anything. Even we don't know by 2025 zettabyte of data will be big or not. And I hope you all are agree with me. But in line with the pace of this big data, and what are the different computing components required, it is AI is not just you pick up and go ahead, because we require high-end computational machines with large storage. And fortunately, we are being supported by good development in programming and algorithmic platform in terms of Python. And something will come again in the near future. We are really not sure about it. So my request to all the participants is that please see that students are, yes, they are getting into all this AI concept, but all the time they are getting into this AI concept with some amount of experimentation, so that it will be more well received by the students. And please see that where this AI is moving ahead. So I will not try to define AI now, but I will be happy if there are some questions from the participants, so that I can answer them in the next 2 to 3 minutes, and then maybe I will try to conclude. So thank you once again to all the participants. And what is important here is, you should be able to tell students that yes, this is what is happening in the near future. And when we talk about this entire artificial intelligence as a bigger domain, as you know that there are many things involved in it, but please see that it is always linked to the some emerging use cases, and that will help students to learn more. Thank you very much. Thank you to Dr. Patkar sir and entire team for inviting me and giving me an opportunity to share my experiences. Due to time constraint, I am concluding my discussion, but I will be happy to answer the questions if any. Thank you. Over to you, sir. Thank you.
Yes, thank you so very much, sir. That was a very wonderful session, and how briefly you explained all the future prospect. That was wonderfully done, sir. Just a request, sir. Yes,
Yes, sir. Over to you.
yes.
Any, yeah.
Uh, Thank you so much for that, sir. Now coming towards the concluding part of the session, if there is anyone who wants to ask a question, we will quickly take it in the next minute or so, because all the faculties have been patiently been good listeners since the morning, and I think it's really time to have a conclusion of this wonderful day that we have. So anyone who wants to ask a quick question, we'll take one, just one. Okay, sir, there is a question from Professor Umesh, if I believe. Difference between AI versus ML.
Yes. Very good question, and very fundamental question that everyone should understand. AI is a bigger picture. If I will ask, I will tell you that if you take example of robot, that is the best example of AI. But if you go to the subset of AI, that is machine learning, so always please make it very clear that when you have to deal with the problem of classification and clustering, then generally we go for machine learning tools and techniques. And when there is a problem of identification and detection, then we go for deep learning, which is again a subset of machine learning, and both deep learning and machine learning are subset of artificial intelligence. But with respect to the example, it should be very clear. When we talk about robot as a bigger picture, that is a complete umbrella of AI. But if you want to go to the Netflix as a one of the specific example, then that will represent example of machine learning. And if you go under again, one of the basic example of disease identification, then that will go as an example of deep learning. I hope your question is answered, Sir Umesh sir.
Yes, thank you so much for answering that question, sir. And I'm once again really sorry to the other faculties if your question was not being asked. I'm pretty sure sir has shared his phone number and the contact details. You can please anytime go ahead and contact him, and you can get the relevant information from there. Now, as we come towards the conclusion of today's wonderful FDP program, I would just like to have a better. We would have loved actually to have a very better interaction with all the participants who have come here, but due to time constraint, I request if any one faculty from our audience today, if they could just share their valuable feedback of as to how today's session was conducted, and if there are any further ideas from their side for our future development. Any one faculty, if you could please come up and just speak. Okay, I
Sir,
think there are.
may I speak?
Yeah, yes, please,
Hello?
please, ma'am, go ahead.
Sir, may I speak? I am from Professor Anuradha Nawate from Amritsar Engineering College. I have attended this lecture, Urban Day FDP. The first session was conducted by Prasad Madam. That session, Madam has deeply covered unit number 1 and 2, and she delivered all the contents nicely. Then second session was conducted by Rajeshwari Madam. Her session was very excellent. I means he has explained each and everything by drawing the picture of that events in the Excel sheet. I very much like that madam session, and in the future also contact her and clear some concept. And next session was that conducted by an our I can see this session, his session was also very nice, and he also covered the unit number 5 and 6. And the last session also was very nice and excellent. That is conducted by an Malay sir. Means we know that Malay sir is always explaining his session by giving an example. When you have to give an example, proper example, that sessions will be keep 100% in the mind. That I means all the speakers was very nice, but from this workshop I extremely very much impressed by the session of Rajeshwari madam and Mahalay sir, and all Prasad madam was also nice, and that Gayakwa sir's session was also nice. Therefore, the whatever may be the programs you have conducted, it is very well managed and very systematic. Thank you, sir.
Thank you, madam. Thank you very much.
Thank you so much for those kind words, ma'am. We are really honored by that you liked our sessions and our honorable speakers so much. We would definitely try and conduct more of these sessions. And as our respected principal sir had mentioned, we would have actually loved to have this session offline. When we get to meet everyone and create a much more happier environment. And so moving on, I would now like to request and call upon. Yeah, extremely sorry for that. Yeah, now I would like to call upon our coordinator for today's FDP program, that is Professor Pramod Salunke sir, who could please come forward and grace us with his vote of thanks, please.
Yeah, yes, Uzeb. It is my privilege to have been asked to propose a vote of thanks on the occasion of the FDP program on artificial intelligence. I, Professor Pramod Salonke, on behalf of Department of Computer Engineering, Bharati Vidyapeeth's College of Engineering, Lavade, Pune. Here, first of all, I would like to give my hearty vote of thanks to our chief guest, Honorable Dr. Varsha Patil Madam, Dr. Pramod Patil Sir, Dr. Parikshit Mahale Sir. Also, I would like to express our deep gratitude to our principal, respected Dr. R.N. Patil Sir, for his constant support and motivation and his presence in this FDB. I extend very hearty gratitude to all the speakers, Dr. Jayashree Prasad Madam, Dr. K. Rajeshwari Madam, Dr. D.P. Gaikwad Sir, and Dr. Parikshit Mahale Sir, for gracing your crucial work and sharing with us your knowledge today, and making an excellent presentation and making this FDB a very meaningful and interesting. So then I would like to thank our beloved HOD, Dr. Uday Patkar sir, for his guidance and moral support. I am happy to express a vote of thanks to our faculty members, FDP co-coordinator Professor Sanket Pawar, faculty member Professor Yogesh Kadam, Professor Prajakta Pawar, Mr. Abhijit Kadam, and our enthusiastic student, Mr. Huzeb Muzawar, and all staff members. I'm sure, I'm sure that all participants are benefited by coming here. So I would like to thanks to all participants who have turned up in such a great numbers. So thank you so much for your cooperation, and thank you very much.
Thank you, all of you.
Yes, thank you so much for that. On by the permission of our HOD Patkar sir, I can now say that the FDP for today has been concluded, and we hope to see you in the near future. And just a few words before we part. Kindly remain in the WhatsApp group that is available that we have joined, because all the further details about our guest presentation and the feedback links will be shared on that group. So please don't leave that group. And also in future, any important news or anything will be shared on that group. So kindly remain on that group, and all your certificates, as it is mentioned in the message, by 27th of January, you all will receive all the certificate regarding today's FTP. So thank you so much once again, and I now conclude the meeting. We all may leave the session. Thank you so much for coming in here today.
Thank you, sir.